Hello and welcome to the second in our sessions on of PhD presentations as part of the Digital Consortium. The purpose of this consortium is to try and establish a platform whereby we can exchange ideas globally. Today, I'm delighted to say that we have four very talented individuals who will be presenting their work. We will have 15 minutes for each presentation and 15-minute feedback from Gustavo Rincon and myself. So I would like to start to begin by inviting Sina Mostafavi to share his screen.
Hi everyone. It's great to be here again at Digital Futures. Basically, I'm going to present my public doctoral thesis presentation, which I defended a couple of weeks ago, and it's a great opportunity for me to share my experience here at Digital Futures. The title of my PhD is Hybrid Intelligence, Architectural Robotic Materialization, Computational Fabrication, Material Intelligence for Multimode Robotic Production of Multi-Scale and Multi-Material Systems. I've done my PhD at TU Delft. My promoter is Klaus Osterhaus, Henriette Bier and Nimish Viloria as co-promoters, and independent committee members are Professor Hensel, Professor Berry, Professor Teufel, and Professor Van Timmeren. I start my presentation with a series of questions which relates to my research. How do we build livable spaces? Which methods we may use? For instance, what are the fundamental differences when we subtract material out of a mass versus adding or assembling matters or elements to build up the target design? Like the example you see on the left, where we subtract materials versus the one on the right, where we add elements or matters on top of each other. How may these different methods result into new models of materializing architecture? And how may they alter past and present applicable models or make future visionary models feasible? In this context, materializing architecture, what is the role and impact of design media in general, and representation, simulation, and computation technologies in particular? In an interdisciplinary setup, what role designers and architects can play to develop advanced and tailor-made design media for more efficient products that may save lives and matters? While we are designing, how we can look beyond the finished and commercial building products and materials by looking into sequences in construction and constraints and potentialities of different production setups. How can we learn from the history of craft and construction, and what other industries such as automotive industry have to offer to architectural production? How do we assess the constructability of a particular design? Is more visually or geometrically simple, more constructible and cost-effective? At least in the case of this monumental building, the answer seems to be a no, as the curve on the left is defined by straight and circular curves, while the more constructible curve on the right might seem visually or mathematically more complex. How can we benefit from geometric complexity in multiple scales, ranging from macro to micro? For instance, on the left, you see macro scale examples where structural stability is achieved by introducing the Sina curve in the sculptural wall, and the video on the right, you see how the Sina curve guarantees the stability at very small scale during the robotic 3D printing process. How can we associate different performance criteria with topological and geometric variation? Like on the left, where in the music hall, variations in the size, depth, and shape of the cavities result in better acoustic performance of the space, and how the use of emerging digital fabrication technologies, with which we can afford significantly higher levels of resolution, as you may see on the right, allow us to achieve better performance considering different criteria such as structural, environmental, and functional. With these overarching questions, in addition to architectural design, computational design, the main subdisciplinary area in this research is architectural robotics, which in summary is about how both as embedded operational robotic systems in the built environment, as you may see in the examples on the left, and robotic building processes, as you see on the right, we can innovatively make use of the programmability and customizability of robots in opposed to single task dedicated machines. In this context, it's published also as a book in 6 chapters. Chapter 1, introduction, follows basically a classic structure, which is introducing the research design, which includes problem and hypothesis statement, research relevance, which are scientific, societal, and environmental relevance, research methodology, and also questions, objectives, and deliverables. And here you find a shortened version of the main questions, which is about how can we incorporate integrated computational design to robotic production intelligence in architectural design and building processes to effectively materialize efficient building systems and products. For sure, in this chapter, the questions are further defined in further details. And here you see the structure of the whole dissertation, which, as you see here, the introduction is followed by a kind of a horizontal chapter about definitions and frameworks, which somehow also cover the literature review, but also try to provide new definitions in the context of this research. And then we have 3 vertical, let's say, chapters on porosity, hybridity, and assembly, which I'm going to discuss later in detail. And then we have a conclusion and discussion. Chapter 2, as I mentioned, is about definitions and framework. So I try to basically follow, do not follow a kind of conventional literature review structure, and I try to basically use my own experiments, but also some experiments in the state of the art or the background research to come up with new definitions and frameworks. And here I have 6 definitions and 4 frameworks. But before getting to the definitions, in this chapter I define what do I mean by hybrid, what do I mean by intelligence, and what do I mean by architectural robotics and materialization in general. And then 6 clusters. I'm going to flip through the clusters. The first cluster is about design systems, computation, and automation, which is about how we can apply systemic and algorithmic thinking in integrated design to robotic production systems. Then cluster 2, topology and geometry, tectonics and component. Pick on the notion of the idea of topology of fabrication and how we can inform the design considering the topology of fabrication. And then it follows with the idea of component-based design and components-based architecture, and basically designing and fabricating families of objects. The cluster 3 is about digital physical integration, which discuss how fabrication intelligence can be achieved by bridging the gap between the digital and physical. And we discuss also ideas such as immediate materialization and mass customization. Cluster 4, performance and variation. I elaborate on how we may approach performance and variation through integrated computational design and robotic fabrication, and how new levels of details and manipulating, for instance, the properties of certain materials may result into better performance. Cluster 5, rationalization and approximation versus simplification, is about how we may embrace the constraints and potentialities of different fabrication methods and how production-related parameters such as tooling, resolution can inform the design. And eventually, cluster 6 kind of wrap up the definitions by elaborating on the importance of interdisciplinary approaches in design, research, and education in the context of contemporary industrial revolutions. Then the chapters conclude with 4 frameworks, which are conceptual, analytical, and operational frameworks. And the last framework kind of connects the whole background research and background studies to the following thematic chapters, which are porosity, hybridity, and assembly, as I'm going to explain in the following sections. So chapter 3, 4, and 5 followed more or less the similar structures. Here I have the more extended case studies. I'm going to be a bit fast in terms of introducing the case studies, but just to give you an idea, the chapter 3 about porosity, on the one hand, discuss the computational porosity and how we can translate, for instance, in this case, discrete results of topology optimization into continuous bar-based elements in an optimized structure, and it follows to the notion of production of porosity and how again the result of an optimized, let's say, structure can be translated into continuous robotic toolpaths, and how this again translation from discrete to continuous can inform the design. Chapter 4, hybridity, discuss two concepts: multi-mode robotic production and multi-materiality. By multi-mode, I refer to the way combination and integration of different fabrication strategies may result into new ways of materializing architecture. For instance, in this case, combination of hot wire cutting with milling, and how different levels of resolution and different speed of fabrication can inform the design. And by multi-materiality, as you can see in these examples, which are actually the early design to production materials that we provided for one of the Digital Futures workshops, it refers to the idea of computing and producing multi-material systems. Back to the idea of multi-mode robotic production, for instance, here you see how combining different techniques of fabrication may result into new aesthetic. In this case, a transition from continuous double curvature surface to developable surfaces, or combining different materials by manipulating the material properties of a rigid materials, in this case cork, or combining structural capacity of concrete or foam, in this case by revisiting the way we usually use mold, in this case by using a four-part mold versus a two-part mold that we usually use, or in this case by combining both subtractive and additive manufacturing processes. As you can see here in this case of hybrid chair, we're combining 3 or 4 robotic manufacturing routines, and all these, let's say, sub-procedures together inform the way we design and fabricate our in this case, hybrid chair. As you can see here, each process is followed by another sub-process, and all together create this hybrid material system, as you can see here in this example. To move on to the last thematic chapter, assembly. In this chapter, I discuss the idea of component and sequence, how embedded connections can inform the way we design and build architectural pieces, and how, again, the constraints and potentialities of assembly during the assembly process may inform the design and assembly, or in this case, how it may result into the way we, on one hand, consider computational design strategies for optimization, but also consider the way we fabricate our elements, and how all these elements together inform the design space and production space. So I'm not going to go through the conclusions in details, but again, as I thought it would be nice to share the structure of a finished dissertation in this consortium, I'm going to explain how this is basically structured. In chapter 6, which is results and contributions, I kind of recap on the objectives and the questions that I had for each of the 4 main core chapters. And as kind of follow-up and recommendations for future works. I've structured the future directions that I would like to take in my research, or anyone else who is interested in this workflows can take. And then this is also structured in three subsections: research, education, and practice. And you can also find more information about my research in my website and my publications. And with this, I can also mention that, especially in TU Delft, there is also another requirement for finishing a PhD, which we call propositions, which we also find it very much challenging, which is about making statements which are logically correct, but it might not be necessarily connected to your own research, which maybe I would like to also pick up on this in the panel session. And yeah, as I said, this is the doctoral committee, as I mentioned in the beginning of the lecture. And for more information, you can find the dissertation on the link on the left, and also the link to the defense, which is almost 2 hours of tough questions and back and forth between the committee and me on the link that you can find through this QR code on the right. Yeah, thank you very much.
Thank you so much, Sina. Really great work. I'd like to say congratulations on finishing your dissertation and presenting us all this work. Now we'll get some feedback from Professor Neil and Professor Philip Yuan on your work.
Yeah, Afarin, Sina, very good. Thank you. Very good. Very impressive. You know, I was just, you left me thinking more. I mean, the work is great, don't get me wrong. But it left me thinking about what what is interesting about what we're trying to do here. And that is to say, a lot of people who are doing PhDs are working in isolation. I mean, it's a very solitary task and quite challenging often, you know, because it's a long task and so on. And but it's great to be able to show everyone else what's going on, for example, in TU Delft. And you know, I think it is very strong work. But it also raises some interesting kind of questions to me. As we were discussing yesterday about different approaches to how you write a thesis, right? And the different modalities. You know, you get design-based ones, you get theory-based ones, and you get, I guess we call it scientific method ones. And yours is a classic example of scientific method. I guess myself, I'm always nervous about doing that. I have to go and submit papers for Acadia, and it says, please keep to the scientific method. And I think, well, how do you write theory according to that way? Would Gilles Deleuze ever get a paper accepted for Acadia, kind of thing, you know? But it's very interesting to kind of get the sense of that. It also, I think what I came across this one was a couple, I mean, some of the challenges. I couldn't help but notice that you had your Cass as your primary advisor, and then Nimish Biloria, both of whom have since left Delft. And it's actually an interesting challenge about how do you have this long-term project whereby you're handing on to other people in a certain sort of way. But I guess, you know, to my mind, it was, I as a theorist, shall we say, that I've discovered there are many different approaches towards theory. And for example, in Germany, and of course you've been teaching in Dessau, you know, the idea is that theory is about finding the solution to everything. And meanwhile, in France, it's always been the question, how do you ask questions? And what, you know, it's all about questions rather than solutions. So you get a multiplicity of different approaches as you bring the world together. So you get a sense of how the differences are played out. Just from my own point of view, I mean, for example, I find it challenging to try and do a literary review where you try and sum up what everyone said without being totally kind of banal. With saying, so I tell my students, please read the stuff, but don't do a literary review. I also, for example, I'm nervous about a case study, because a case study can only be a very superficial take on something. How do you present it? But it's clear that you've kept very closely to a particular model, and I think this is an exemplary model of how one might operate. So I just think I haven't got much to say apart from that. Well done. This is really, really, really proficient. But it does raise some of these interesting kind of questions about, what are the challenges about working in a PhD and how are the different modalities of operating. One question for you is, how long did your PhD take?
Actually, a lot, around like 8 years, because at the same time I was working and I was practicing, so I had my own practice. And for 4 years, I was also teaching in Dessau, and also I had the studios in Delft. So I have been a researcher in parallel to my PhD in Delft too, researcher and senior researcher. So it took a long, let's say. It took so long, but at the same time, back to your question, how maybe I managed to keep it up and keep it going, was through the way I managed to create anchor points in education and research projects which were running in parallel. And that was the only way that I could basically manage to bring everything together. At the same time, I was thinking at one point, maybe I could, for instance, finish my PhD only focusing on one of the thematic subjects like porosity. So I had like three topics. But at the same time, I'm happy that I managed to create a kind of an overarching, let's say, materialization model, which is something that I can actually continue in future. And back to the question of literature review, which I find it very, very much tedious, especially when we are doing this design-oriented PhD or research by design or research by prototyping. So at this point, I feel that I'm ready to do, for instance, 3 hardcore literature review papers on those thematic subjects. But if I wanted to do it the other way around, I would have spent like 3 years or 2 years only doing literature review, and then I would have missed the time to actually do something. So this is somehow tricky. I totally understand that sometimes you want to get deeper and deeper in the literature, but at the same time, I feel that when you finish the work, if it is let's say research by design and research by prototyping kind of a PhD, then you would have time, and you may even do it better if you do it after your PhD, a kind of really focus literature review, for instance, on porosity. And I'm really open to do that. But I don't think we can have both at the same time.
Just a couple of things I wanted to pick up. One is that, I think your issue kind of raises the challenge actually of how one can survive during a kind of doctoral research, especially if you come from a country like Iran, where you don't have as financial resources you can play upon, and the necessity to try and survive by teaching alongside that really highlights some of the real challenges. And of course, the other challenge is, frankly, the question of fees and scholarships and so on, especially if you're from Iran. There's no way you can even afford those things. So that's an interesting kind of question. What I wanted is just to kind of like highlight those, or put to you as a question is that what I the sense I get, because it is a kind of very thorough but quite wide-ranging PhD, it is not maybe the primary focus trying to conceptualize a kind of a structure in itself, a workflow, how you understand, how you situate each part of the work. It's almost like that is the main emphasis, to try and understand within a broader structure all these different components and how they fit together. Would that be fair?
Actually, that's a very wise question. One of the independent committee members of my PhD was Professor Jane Berry, and she also brought up this issue. In my foreword, I've mentioned a story, a story that I borrowed from my mom, actually. When she was once decorating our house, she asked the mason to carve out a niche on the wall, and inside that niche again carve out another niche, and inside that niche again another niche. So I kind of borrowed this analogy in my PhD, saying that PhD is very much about creating a niche inside a niche and inside a niche. But at the same time, when you do a PhD, as the time passes by, you figure out that that very small niche that you find, I don't know, in the first year of your PhD, after a while is basically a gigantic space, and other scholars are also fighting in that very small niche to do the same thing. So on one hand, it's about struggling to find new niches, but at the same time, I think if you change the anchor point, or this jump from one niche to another niche, you may lose the grip, in my opinion. And that's something that it might be also important when you want to manage to finish a PhD. And again, back to the defense and the question that develop workflows and how while we are using robotic fabrication and computational design, how where can we start, and what are the fundamental aspects of materialization, and it might also sound very let's say somehow trivial if you think about it, if you think about these three topics of porosity, hybridity, and assembly. But based on the experience that I had in teaching, I found it very much helpful also for the students. Where do we start, and how this abstraction can also help us to be creative, but at the same time to the point when it comes to materialization using robotic fabrication.
Thank you. That was great answer. Thank you.
We have 5 minutes left for feedback. So Philip, if you have some questions.
Yeah, and hi, and Sina. I jump in the lecture, maybe only half of it, but I think it's great work because we met together in RoboArch twice. I think
Yes.
in the past few years, you're doing really impressive work. I can remember. So as a specialist in robotics, I think Sina doing a long-term research and focus on different scenarios and explore different possibilities to set up this kind of human-machine collaborative process in the materialization by the robotics. I think I understand what's new put forward me. Probably the topic, especially your presentation today, is a general description of your research in the past few years. Is crossing through different scenarios, different topics, and different projects. I think it's more like a category or like the whole category of your research. But I think as to a university, robotic design is really new to, I think, different schools, especially in the past 10 years, over the past 10 years. But right now, I think the trend is going to more like focus on and not only how we make use of the robotics, but why we make use of them. So how to engage or introduce this platform most meaningful to the whole design and the construction process. So my question to you, you just put forward your future research interests, and the most impressive is still the high I think, which is the let me open. I think it's probably is your cyber physical design to production and operation system. I don't know what's the most specially any platform or any operation system already set up by your team that is unique, set up some working flow or the software platform or the special toolbox you already contribute to the society or from TU Delft or from your research. Can you make a very special introduction for your special contribution to the community? And can you make some very special introduction on that? What kind of working flow or the toolbox or different kind of software you develop as a very representative work from your contribution, your thesis to the robotic community? maybe that's my question, because I'm missing the first half part of your lecture.
No problem. Yeah, thank you. Actually, that's a very good question. If I want to mention the work that we have been doing in Hyperbody Research Group and robotic building, actually one of my colleagues who has also been a PhD, Liu Chang, he has done his master in Munich, in München, and together with him we were conceptualizing the way cyber physical systems and robotic production can be combined. And we were running basically studios or research, which I can also share some of the links to the papers that we co-authored together. But I also agree that these two realms, like robotic operation, like the way we can see in adaptive architecture or interactive architecture, and robotic fabrication can be combined together more. And that's why one of the major future directions, I think, is cyber physical systems, where we can embed robotic systems not only in production lines, but also in the buildings. So, but my research has been mostly focused on robotic production and not that much on interactive design and adaptive systems. But at the same time, for instance, I can also refer to one of the sessions that we were co-chairing with Biana Bogosian on immersive robotic environments. And there, I think we try to kind of formalize and summarize the way robotic systems, design media, and robotic production can come together. And I think I'm personally very much interested to follow that track. But when it comes to fabrication, I think integration of AR and VR environments in the design and production is also another field that I'm trying to basically get more involved in those projects, and I'm interested to follow that direction. But I think that session, especially that we had together with Biana in Digital Future, is a good example on how we can navigate in this interdisciplinary environment.
All right, thank you so much. We have to move on.
Thank you very much.
Because we have more presenters to see. So our next presenter is Anna Fonte. She is a second-year PhD candidate at the Architectural Association. Her research titled "The Ordinary Noble Towards Genealogical Architecture." Anna is an architect from the University of Ramon Llull in Barcelona, and she got her master's from Harvard University, the GSD in Cambridge, Massachusetts, and is a PhD candidate at the Architectural Association, as I had already said. She has worked in Buenos Aires, Barcelona, Boston, and Tokyo, and she is currently in Barcelona, I believe, where she is presenting from. And her research engages archiving of architecture, registers, compiles, and organizes the scope of extracurricular activities at the school, and produces a series of publications, Archivos de Arquitectura. Welcome, Anna.
Thank you, Virginia. Thank you for the introduction. It is really a pleasure to be here today. I've been enjoying the intense environment in this platform these past weeks. It was a bit new for me. I think some of you guys have been more recurrently around, but it's really a unique space. So thank you for having me. Let me start by contextualizing a little bit this particular moment in the process of my PhD research. Virginia already said that I'm in my second year, but I wanted to say that my director of studies at the AA is Mike Weinstock, and my second supervisor is Marina Laturi. And I am in constant unofficial dialogue with Ciro Nagle to complete the constellation. And yeah, I'm in it in my second year, and I'm just now starting the production of the thesis in its parts with a hypothesis as a backbone for it. So today I'm going to present this backbone, and even if I'm pursuing a PhD in design, I'm going to do it without images so that the construction of the argument can come through at this time. So I would like to start by positioning the research under the consideration that it is a cultural theorematic construct. By this I mean that it is not about a programmatic problem, neither is the construction of a technical apparatus. And well, with this I am also positioning this research in a threshold regarding certain traditions of the practice of architecture. And by doing so, generating somehow a double friction. And that is very helpful for me in order to set the boundaries of the proposal as well. In the research, I consciously decide to engage with a certain vitalism, let's say. And by vitalism, I mean a tendency to activate materials and keeping them in motion, avoiding destabilization in given cliches, in which they can so easily fall, especially in this digital arena. So this constant mobilization to reflect upon the state of architectural production is articulated towards the question of how computational thinking is triggering a space for novelty today. And well, the title of my thesis, it is toward a genealogical architecture, a machinic taxonomy. And the concept of the machinic, it's very, very important. The thesis is constantly contrasting itself in relation to this machinic characteristic, which starts at the scale of the thesis as machine. And of course, this is a Deleuzian term. I would say particularly in the reading on the treatise on nomadology by Gilles Deleuze and Félix Guattari, and the way that they introduce how to relate to materials in that particular text. So the condition of the machinic in a broad sense, and I'm going to be broad in this presentation because it's short, but I want to introduce the main points, consist on the one hand in maintaining an exteriority of one's own assumptions as an essential component of uncodified thinking. What I mean by this is that it's important for me to consider that ideas are not inert, that objects are not closed figures, instead to look at them as systems of relationships that are variable, that are mobile, and that are fluctuating. And because of this condition, what the machinic involves also is determining the spatial, the arithmetic, and the affective aspects of the materials that we work with. This means that these materials have form and that the relationships are not infinitely elastic or exchangeable. They have configurations and they assemble in certain degrees, and the particular modality in which they assemble constitutes its own form. So it is not like an open system, absolutely. So in this context, the thesis presents itself not as a process of deduction towards a set goal. Instead, is the construction of a medium that can reshape and integrate ideas as it evolves in a regime that is indeed open and as well as it grows inertia as it evolves. And this medium starts in the field of paleontology. I want to introduce you into a term into a world that maybe you already know, that's particularly in the realm of theoretical morphology, because in paleontology as a field that is occupied with fossil record, which by definition is incomplete, there is this need of theoretical projection of organizations in between what is known as individual organisms that have been actually found and they are evidence for certain forms of living. But to cast light on the overall spectrum of this found evidence, there is a need to project like theoretical in-betweens. So theoretical morphospace has a very particular configuration that it's called, indeed, that like this space of projection, that what it does is to construct geometrical models of living organisms and the variation, and they simulate the variation of their morphology. This space is very simple. It is a cube that can have as many levels as relationships that model has, and the relationships are very basic geometrical relationships, like if they are studying shells, the height and the radius of the shell in relationship with each other, or the quantity of cavities, and so on and so forth. So this kind of very clear scientific way of dealing with this problem of the unknown and how to project knowledge from actually the theoretical in between the known is the functions as a precedent for me as a mode of configuration. And the thesis is going to aim at constructing a sort of architectural hyperspace, a sort of evolutionary engine that methodically conceives possible architectures. So it is a classificatory space with the capacity to draw continuities and gaps between materials of study, which will be considered as chances for a simultaneously fluid because we work alongside relationships, but also disruptive because these relationships have limits that are embedded in these individuals that break towards transformation. So the classification works both at the scale of the lineage as something that also is projected and emerged, and its individuals. So things are as important, like individuals are as important as their field of variation, but this doesn't mean that the model is naturalistic because it does not enter in a process of mimicking, and it is not retrospective. It is a creative method. So in simple words, what I'm saying is that this classificatory system can be projective if approached in these terms. And this on itself destabilizes existing classifications, because what happens if we introduce a new member in a grouping? Somehow that redefines a family to which it belongs, right? So my intention is to introduce theoretical projects in the tissue of architectural production to alienate the stability of certain groupings and generate new architectural configurations. And I want to go through 4 ideas that will kind of concatenate and allow me to be more precise about how I plan to do this. One is the idea of history, then form, the idea of computational model, and finally the idea of value. And I want to start with what is the particular idea of history that I'm approaching here, because as I've been saying, I will be working with architectural materials, and the thesis proposes that architecture is made out of the materials of architecture themselves, particularly buildings, as unit of study. And by considering history on a chronological field, I will be looking through the lenses of Stephen Jay Gould's punctuated equilibrium theory, that, as you well know, it opposes the notion of gradualism to that of speciation. In this context, I consider 2 things that are also broadly known. First, I will be considering that the discipline case study record is a field that is latently and constantly being built. It's full of gaps, and it has peaks of innovation and production, and any linearity that can be recognized in them, it's a local intellectual construction, but it's not an a prioristic condition. The second is the relevance of the unit. This case study, I'm using the word case study, but is this singular manifestation through which to reconstruct overarching tendencies and overarching logics. So this case study becomes a point in this continuum, the continuum that I was kind of describing before, of this set of relationships specialized in this kind of engine that can be linked to any other. But how are they linked? They are linked by means of the traits that they share, right? Like the characteristics, the very specific singular characteristics that they share. So the punctuated equilibrium principles allow the thesis to go from the striated plane of classification, or what would be considered an striated plane, of course, if it is so highly determined, to the smooth space of the machinic phylum. And this happens by means of the case studies as units of meaning. So if these units of meaning are going to be the next, let's say, scale of with which I'm going to be working in the thesis, inside of this framework, how is the description of these units in terms of what is the idea of form that is embedded in these units of meaning? And here is where I'm interested in claiming somehow a response to the reduction of architecture to a morphologic problem, and introduce the concept of assemblage into the discussion. In the field of theoretical morphology itself, the geometrical model of an organism is built, and I quote from McGee's book, an assemblage of architectural features. So this is what we broadly known as the Bauplan, right? Which is a term that integrates the analysis of function and fabrication as two components in a geometric model. But if we add to this reading the notion of the machinic assemblage, the technical element, it has its usage, of course, but it also has a model, an extension, and a comprehension, and an affect. So the model of such technical element resides inside this assemblage, and it's not reduced to this collection of materials. I think the other day, Manuel de Landa was mentioning this relationship between the assemblage, the Deleuzian assemblage, and the Hegelian totality, and this resonates with it a little bit. But nonetheless, what I wanted to introduce very importantly, very centrally for me is that this assemblage is not only morphologically based, it has other components to it. And this assemblage is a computational model. It has to be produced as a model. And to think in those terms that I'm just kind of building up upon, I find myself with the need to go back somehow to what I will call momentarily the avant-garde of digital design and reintroduce a discussion on complexity theory. I think this...
Anna, you have 1 minute left.
Oops, okay, well, I'm gonna rush it, sorry. So very quickly, by introducing this realm, what I want to do is transcend this encapsulation of the idea of form as shape and introduce the dynamic organization in the model, which means claiming back the differential model of organization as a way to generate these computational relationships. So lastly, and then I'm jumping a little bit to the end. The last thing that I want to mention is, well, how do you select these units of meaning? No, what is at stake in that? And because the construction aims to be a projection of this achronological association, the mobilization for the selection of material consists in the identification of disputes. And the process of cross-association is based in the acknowledgement of disciplinary frictions between these case studies. And then the modality of assemblage avoids any process of selection by formal resemblance or by reconstruction of families of analogous objects as an end on itself. And because of approaching it in this direction, what happens is that these emerging phyla can be predicted that are going to be built in a trans-typological way. And this is a result of what I was mentioning at the very beginning of how the approach is theorematic and not programmatic, because this selection criteria will be the medium to deterritorialize the condition of typological record in architecture as a universalizing categorization. So ultimately, I would like to propose a shift from type to trait, to the idea of trait as a mobilization of the way we describe architecture. And finally, inside of this trans-typological taxonomy, I think there is also a potential and the capacity to generate these new categories or new species. Thank you.
Thank you so much for that presentation. Very great. Why don't we get some questions and comments from our critics now? Neil, Anna, Philip.
Yeah, can I? Could you stop my video? I can't.
Yep.
Yeah, no, Anna, that was terrific. Actually, it was a very beautiful contrast to Sina's work, and both are very valid in their own way, but they do kind of point towards the differences of approaches. And I was particularly taken by the fact that you were presenting without any images, and from a theoretical perspective, I think that the three greatest theorists that I can think of anyway, that we have or have had in architecture, I would say they're probably Sanford Quint, Manuel de Landa, and Mark Cousins. That, to my mind, that's my own personal take. But each of those, none of them would show any images, which I think is a really interesting idea or challenge in some senses. And I'm often in a situation where I write something and people say, well, what are the images? You've got to go with it. And I somehow find something to put in there because they want one, but do we need it? And I think what it highlights is really you highlight actually what is the question of architecture. And actually, it's not building. If someone says architecture is building, it's not. Architecture is a discourse about buildings in which those objects are inscribed within a narrative that makes sense of them in some way, in a very kind of highly subjective way, perhaps, but it makes sense of them. And I think that was really, really powerful in what you were saying. The second question, which I think is really also super interesting, because it's another issue that I'm facing the whole time, and that is to say that, you know, what you're doing is, I think, challenging a certain kind of classical way of approaching things that actually Sina was following in some way. You were destabilizing it, and I think, you know, kind of alienating it, looking for gaps and so on, and calling to question that thing, which I really, you know, I'm not just nothing to say against what Sina said, which was really fabulous in its own right, but I think that's a really important thing, because, you know, I think that the danger comes out of that view where if you think you can wrap things up and really contain them with the PhD and come up with a conclusion, that's a bit of a myth, you know, because you can't, you know, and I think in some ways I find myself in a situation whereby it's better to ask questions than to come up with conclusions. And I think that your provocation is really very interesting. Let me finish off with one thing, and that is to say, actually, this is quintessentially AA work in some senses, because when I was teaching there, and actually Cyril was a primary example of this. I mean, he was by far and away the best studio teacher. He's the most popular. Famously, he turned down Neri Oxford at one point, but anyway, really good. But his strength came from the kind of the theoretical debates that make sense of it, and indeed the milieu in which it was happening, and people like Mark Cousins in the background really kind of like, you know, raising the intellectual level with the kind of theoretical debates. That's what made the AA so strong at that time. And actually, it wasn't just strong theoretically; it was strong in terms of the design that was coming out. And, you know, people like Aki Menges were coming from that school, as well as Neri and a few other really, really talented things. So I'm delighted to see this kind of theoretical reflection that, in some ways, destabilizes the model of that often we expected to conform to, and it's become the dominant model, the kind of scientific research model that's very straitjacketed, and you're really calling it in question in a very beautiful way. So I'll stop there because I can go on forever. But thank you, Anna. That was really a delight to hear. Thank you.
No, thank you, Neil. This is really nice of you and very generous. No, it's the first time ever that I present with no images, but I was like, I felt like it was fitted, and yeah, I think it's very challenging, and you need to kind of, but if it becomes an illustration, then it is self-defeating on itself, and so I think it's something to pursue, and yeah, also to kind of build up the context in which we are thinking, because there are many things that are becoming so self-explanatory, but then they get encapsulated. No, and the other day, Manuel was saying this thing about the totalities, and I thought this is really complicated in terms of the digital. No, we will be exploring this in the workshop in the other week. No, and trying to untangle the lineages and to try to kind of break through the kind of encapsulation of certain things. But I really appreciate your comment. Thank you.
Anna, shall I make some comments, quick feedback? Appreciate the presentation with no image, the theoretical thinking on digital architecture. I think what you mentioned, if I understand what you say, which is about the machine process, is not just a presentation of the form or the typology or prototype research, but matters more on the social process and how to reorganize the form from not only the formation process, but also the social process and maybe how people to make put all the architecture together, and including logistic, this kind of things. I think it's a totality you mentioned is kind of a holistic vision on the machinic process materialization, re-understand the materialization in the digital age. But I think probably if you want to analyze certain kind of thinking, is there any possibility to go straight more deep in the discipline itself or in the industry itself, including how to make a building in different social background, including in the States, in UK, or in Asia, in China, is all different. Actually, the architecture form is quite different on this planet, is sometimes because of designers, sometimes because of the the social organization, and including the code, including how we organize the designers and the fabricators. So I think it's really meaningful to make research on this kind of social process as kind of a representation of the materialization of the architectures. So that is a very interesting topic, but the most impressive, actually, someone should put forward the interesting question to critically think about what kind of social process is more meaningful or for the future. I think we should saving the energy. We should make the building more efficient, and we should save the labors probably. So all this kind of ethical or the social reorganization thinking methodology will help the how to make a building for the future. So I think this kind of theoretical thinking is really sharp and really meaningful. But what I appreciate probably should be not just from a philosophical perspective. Probably if you can collaborate with some different scenarios of different social process, will be more attractive for your research, which can facing more the real problem and critically give comments to them. Maybe will give a more reasonable framework what you want to set up for the future.
I see. Thank you for this comment. I think, yeah, when I bring up this idea of model that is a complex system, I think it is because it's been a bit naturalized that models are this kind of tendency to prototype generic conditions. And for my reading of what you're saying, and I completely agree, is that we should be thinking again on more holistic models that include all the components that the production of architecture includes, no? And I think this is very important. I think this discussion is not so much on the table in general. I mean, my research at this stage is kind of setting these grounds, but I'm definitely going to move forward into design. But I feel like this is a project of design on itself. But I don't see this as a, I mean, I'm not a philosopher, and this is not a philosophical kind of state, no. But I think that, yeah, it is indeed very important to open up the processes, and so that they don't become disguised in representation. Because I think all these kind of emergencies that are happening lately are being included in architecture, but it's in a sort of representational disguise instead of being included in the model we think and produce architecture. So I think it's really something to take into account in this particular moment in time before it kind of gets diverted from architecture into some other realm, right? But I will definitely reflect upon what you mentioned.
Can I just raise? Actually, this is a very interesting discussion. I mean, I would take a very different view, Philip. I really don't think that Anna should do that at all. I think Anna should persist in some way in this really almost uncompromising way of approaching things. I mean, I don't think you should need to apologize, and I think it's really very rich. The example I wanted to raise really was the kind of question of what is the difference between a book and a movie, you know? And I guess what is interesting about a book is that you're forced to imagine, you're challenged to imagine what the subject is. A movie lays it out for you, and in many ways, a movie's kind of banal compared to a book. So, you know, but I think this is a really important challenge, and we operate in a discipline that unfortunately is completely aestheticized. I mean, really, and there's a lot of discussion about that and so on. You know, and almost like you have no platform unless you show images of designs and things, and people kind of get almost distracted by that. You know, I almost find that it's best to focus on what the issue is you're trying to do, and not bring in these designs, because they'll suddenly start talking about judging the designs in some way. So I don't know. It's very interesting when you get so many different approaches towards what is research, and we're seeing this now. The more you bring together the world, the more you see the differences between approaches, and I think it's healthy to keep that diversity alive. I think that's important, and not to kind of like reduce everything down to a kind of bland common denominator whereby everything is kind of the same in some senses. But you do get this challenge when you're operating internationally of let's say, differences of understanding of how you approach things. I've always been struck when I've been working with, let's say, the world of philosophy. You come across a term like space in Henri Lefebvre, which is nothing like space as we perceive it in architectural culture. So you're going to get misunderstandings and so on. But I always want to say that what I almost feel that you should be doing, Anna, is really presenting a case for why we shouldn't be kind of constrained by this kind of classical model that is becoming everywhere kind of endemic, because people are saying, no, what is the structure here and things. I think it's important to resist that, and I think the message that comes out of your kind of, I guess, primarily Deleuzian take is that we mustn't reduce things down to a kind of a territorialized, fixed, striated structure. And the kind of organization that is kind of is fixed, but remain fluid and adaptive in our approach in order to open up questions, so it becomes like a body without organs. It has a kind of system within it but it's not constrained, it's not fixed, and it's alive. And I think that's what I really got from your presentation, was a richness of a theoretical reflection critiquing a standard approach. So I would encourage you to carry on. I mean, I think this is absolutely beautiful work, and you shouldn't compromise. You should really be pushing that in a very kind of relentless way, in the way that I think people like Delanda have done before, and really set us examples for how to rethink what architecture is. And just to go, just one term again, I just want to mention the term machinic is a beautiful example of that, because what Deleuze means by the machinic, it's absolutely not the mechanical. It's something much more richer and deeper than that. And I think it's that kind of thinking you're tapping into. And I look forward to reading the results of this. I think this is fantastic work. It's really, really wonderful. So congratulations.
Thank you. Thank you so much. Thank you. Virginia, I don't know if you're on.
Yeah, we have 1 minute left. So if anyone has any final comments.
Sorry,
Yeah.
I have a comment. Sorry, thank you, Anna, for your presentation. I think I would be in between both Neil and Philip here. I guess that I would love to see you go and be completely creative, but at the same time, there's a tradition of philosophy engaging with a practical project, even if it is theoretical, because then we have a ground, we have material that we can all look at in our own different languages and methodological frameworks, right? So I could easily see you maybe not apply a certain type of image, but you could apply digital code. You can even apply diagrams. You can even look into physics or mathematics and look at a different way of creating a logical framework that someone can understand deeply, but very good, clear, and exciting work. And I guess one aside, sometimes, your discipline architecture has a certain type of formality and domain specialty, like logic. So I would maybe look at different other disciplines, either in the extreme sciences, I would think like Manuel Delanda, or mathematics or physics, and maybe test those other domains and frameworks. Because I think what Philip brought up with is the social process. I mean, everything is a social construct. So you can even critique all of reality if it gets to that extreme. But thank you very much for your presentation.
No, thank you. Thank you so much. This is really, really good for me. Like, it keeps me thinking. So I get new energy with this. So thank you so much.
But I think, sorry, just to comment, Gustavo, but there are so many different approaches to philosophy, pragmatism being one of the ones, and that's something that the post-structuralist tradition was trying to resist in some ways, absolutely, totally resist that. And I learned a lot from that. And, I think these are governing principles that allow us to remain alive and not constrained by these rigid structures that sometimes are kind of banal, and architecture, to take it to a level where it's not banal requires this difficult thinking that doesn't conform to these easy models that we have. And I think this is exactly what Anna's doing. She's pushing the boundaries of the discourse itself and really destabilizing something. And I just want to finish off one thing, and that's to say that, a comment that was made by by Leotard a while back about the problems of education now. It's no longer a question of why, but how much you're doing, you know. And I think going back to that question about why we're doing it in the first place, to kind of question architecture, is really, to my mind, so important in a world where we're forced to quantify, you know, how many publications have you got, how much research funding you've got, and things, which ultimately is completely banal, you know. And I think, you know, to really just keep this insistent questioning going is the way forward to really keep architecture discipline alive, and not just falling back on these standard tropes and standard models. So, but you know, it's important to see that there is a difference of opinion, and that's what's so important about architectural discourse. If we were all doing the same thing, it'd be really boring. So, you know, there's a range, and Sina and Anna were just presenting very, very good examples of two fundamentally different approaches, which I thought was beautiful, absolutely beautiful.
Just one follow-up. So I would agree with Neil too, but you know what Philip said is very important. You know, we're at a time where we don't have infinite amount of time or infinite amount of material, and we're basically confronted with real problems. So my question would be, how would you communicate the edge of your research if you are going to be critiquing all of these systems? How are you going to communicate to a student that has all the ability and the energy to change the world, but they can't access it because their worldview is so different? So I think this would be, for me, a matter of communication, process, methodology, and pedagogy as well. So I don't know if that would be something that you would like to add to your dissertation, but I know in my work, when you combine high theory with structure, you do confront the issue with theory. And I am 100% a supporter of theory, for sure.
But all right, we do need to move on.
One small point.
Final point.
The final point. Real problems. I think the problem is the notion of reality itself, and this fixed notion of reality. When people say real, I say, what do you mean? As soon as Coca-Cola calls itself the real thing, reality itself is contested domain, and we can't simply fall back on these simple models. That's a provocation to end, so sorry.
I think Virginia will kill me if I get engaged into this, but I have a lot of things I would say. So
yeah, maybe we can move some of this conversation to the chat while Ahmed presents. So I'd like to welcome our next presenter, Ahmed Hassab. He doesn't need very much introduction because he is so well known in Egypt as being one of the leading computational designers with over 13 years of experience using Rhino, 9 years of conducting computational design and fabrication research in Egypt, as well as teaching workshops and other things through his platform, reparameterize.world. He has such amazing initiatives for free education and teaching young students about parametric design. He is in his, just finishing up his first year as a PhD student at the University of Cairo. So welcome, Ahmed.
Yeah, thanks, Virginia. What an amazing introduction. I share my screen now. Okay, so you can see my screen now.
Yes.
Okay. Hello everyone, marhaban bikum. My first question is, yesterday I found this photo while working on the presentation. Usually I used to question everything happening around. Especially I have a desire towards exploring technology and experimenting its application, and this should not confuse me. Anyway, sometimes when you get excited towards something or an idea, you thought it is the most important ever, but unfortunately not usual. So this image remembers me that every day I have to ask myself why, when, and how, and this is my daily questions. 2018, I started my PhD courses at Cairo University as a part-time student. 2019, COVID hit the world and the world is shaking. 2020, the wave is here in Egypt, so I have to pull myself together. 2021, we should keep going on. We should not stop, even if the university campus is still closed till now since 2019. Anyway, my presentation today is more about my journey, which is a product will follow. I am Ahmed Hassab. lecture assistant at the American University in Cairo, senior architect at Engineering Consultants Group, and teaching in other various universities. He's in Egypt as Ain Shams University and Galala University, and Virginia introduced me like my background and so on. As a part-time PhD candidate in building technology in architecture engineering at University, it is possible that I finish my PhD in 2023 or 2024. I finished my master's in 2018, concluded in a published paper in Cadria, February 2020. I'm graduate in 2012 and finished my military secondary education in 2007. Building with complicated chips, excellent quality, and inexpensive price are sought after by architects who are continually on the lookout for novel ideas and design approaches. Usually, they are pushing the limits of digital fabrication and design process in order to design better building envelopes. Despite the recent approaches to generate unique surfaces using generative design algorithms, there are still challenges, including teaching machines how to learn how to manipulate surfaces, thus generating novel and unique versions and exploring possible alternatives in producing unique surfaces by artificial intelligence. My main goal is to find out how, by utilizing computational methods and AI and using a sustainable material, we can design and fabricate advanced facade panels. So I'll start with few observations. Maybe everything is connected, maybe everything is related in nature. They have rules somehow. So very simple observations and basic analysis conclude that there are rules in nature and specific accurate sequence in their design and geometric composition. We can see in the different compositions in nature how it has rules and growth theories and so on. Also how a tree can grow its roots somehow in any environment, being able to survive where it is, considering all the factor aspects, obstacles, and so on. Nature always holds innovative advanced structures and fabrication techniques. So I started to observe what fabrication techniques and structures is out there, what nature can bring to me like as structures is already available for everyone. So I started having a lot of observations like this one. Isn't this additive clay manufacturing made by a bird building his nest? Isn't this as well a clay manufacturing, additive clay manufacturing by a wasp building his nest? So I started digging for more observations, what nature has, what is already available out there in nature. So there is a beekeeper one day just messed to both the frames on the bee nest, and after a week, this is the result. And his wife say absolutely stunning. And from my point of view as an architect, this is something exciting, how nature produces something abnormal when it don't has limits, like when we stop putting obstacles. And other beekeeper shared this photo as well. And he mentioned the same point when he didn't put the frames for a week, and then the bees produced their nest on their way. So I started looking more what I can learn from this. So I found an artist influenced by the same idea, but he started manipulating the surrounding environment where the bees building their nest. So he was able to produce Cleopatra head from a 3D printed tessellated structure, very simple structure that the bees used to build their nest around. So they are designing while building, they are building, fabricating. There is a lot of observations in these pictures. So I have a lot of questions actually after looking and digging for observations. How creative they are. I'm talking about nature and creatures out there. Is there a possibility to use AI network to analyze the process they have? Can AI and computational tools predict possible strategies for design and fabrication, such novel original forms? So I'll put a reminder. My main goal is to find out how, by utilizing computational methods and AI and using a sustainable material, we can design and fabricate advanced facade panels. Usually, I prefer to start with material exploration phase, so I decided to look for a sustainable local material that can be reused. In parallel, I was working in investigating materials and do some analysis. So this is a local bird nest, what I have now in my office. I don't know if you can see it from my camera or not, but this is images from this nest. I went from the countryside looking for natural structures out there made by birds and wasps and so on. And this is one of the nests made by a bird, combining straws, mud, and so on, making a composition of hanged structure. And there is other structure found out there. It's a wasp nest. I don't know if you can see it from my camera or not, but it is in my office. And I found it in Egyptian countryside as well. So I started doing analysis on the material itself, they used, the composition, and the process they used for building this kind of advanced structures from my point of view. And after that, I moved for experimenting a sustainable material clay mixture by utilizing the tools and the methods. So I went for the Egyptian market looking for natural sustainable materials that is affordable out there. So there is a clay mixture, 100% local material, very rich material, and also available and so cheap. If you can see this pottery, it is available in every Egyptian house. It is made 100% from clay. So using a CNC as a 3-axis robot and a clay extruder, I started looking for possibilities using this 100% natural local material and the tools, what I can produce. Can I look for possibilities? And after that, in this experiment, I developed a grasshopper code that can generate the tool paths for the CNC machining and simulate the workflow of the material deposition. And in this video, you can see the CNC moving as a 3-axis robot, depositing the clay, considering the heights, the possible heights, and so on, from what I learned in my physical experimentations, which took more than like 7 months or something like this, experimenting the material itself. So after experimenting the material and its physical characteristics, it is reusable. I can reuse it. It's fine. It's so affordable. And so using the machine and the script, I could push the limits of its physical possibilities. And in mid-2020, something amazing happened. Something changes the course of history from my point of view. It's Digital Futures 2020. I got lucky to attend a workshop by Daniel Pluyan about using AI and attend a few lectures by Professor Neil Leach on how you can use AI and implement this technology and experiencing techniques either in design or anything you would like. You have to design the network and use it. So I worked on like an idea which continued followed and published about generative design methodology for double curved surfaces using AI. So it's about running the cycle GANs, Pixopix, and Grasshopper scripts. Experiment results demonstrated how the proposed generative design methodology using AI can propose unique versions of surfaces, and you have a full control on it. So the experiment was somehow complicated on how you can generate images and then take it to Grasshopper to generate just like a pattern, and then take this pattern back for the GANs network to generate and manipulate the two surfaces together, and then take it back to Grasshopper to generate the final surfaces. And this experiment documented here. So there is real A and real B, a surface generated by Rhino and Grasshopper and other surface like a bump surface, exported images, went for GANs network, and then come back for Grasshopper to regenerate the surface. And this work is published. I published it in a paper in ASCAD 2021. You can look for it if you would like for full detailed. So generative design using AI is promising and helpful in developing futuristic designs using machines, which will be beneficial to tackle new possibilities and alternatives. After that, I started looking for more possibilities involving human-machine cooperation. I started other experiment like, what if I draw a sketch and then send this sketch to an AI network that I developed with a friend, Hussam Al-Din, in another workshop, and then visualize the sketch defining the facade element. In a workshop we taught in ASCAD 2021. So I took it furthermore in experimenting on more sketches and what I can do using AI. Can I visualize the facade? Can I define the architectural elements, the opening, the heights, the skyline, and so on? And it has a promising results, as you can see. And what I have like a conclusion from these two experiments using AI, maximizing the training data set as possible with high quality and clear images is so helpful for accurate transformations and increasing the epochs. So there is direct relation between the training data side, number of epochs, the quality of outcomes, and that is what learned from early experimentation. So AI and computational tools opens a realm towards new possibilities in design and fabrication, especially using sustainable materials, and extend its physical possibilities through design by fabrication techniques. And the research continues on exploring. Thank you.
Thank you so much, Ahmed. Really great research and quite interesting. A lot of possibilities to discuss there. So let's bring in Professor Neil and Professor Philip to give some feedback.
Yeah, Ahmed, thank you. That was a very impressive work. But I was left with one overall thought, and that is to say, you showed us different examples of let's call it intelligence. You know, there was a kind of material intelligence, if we can use that term. Do materials have intelligence? Probably not. But anyway, let's put it in inverted commas. Biological kind of intelligence for sure. Then there's an AI and so on. It struck me, and this is part of my own sort of findings, is, you know, when I've been looking at AI from a kind of theoretical perspective, what I've discovered is that basically you get neuroscientists interested in AI and AI people interested in neuroscience. And in the end, what you discover, you got these different people. They either have a PhD in AI and do neuroscience, or a PhD in neuroscience doing AI. They actually interested in intelligence itself. To my mind, the quest for AI is the quest for intelligence itself. And it seems to me that what you're kind of uncovering are different facets of intelligence in some senses. And so I wouldn't necessarily get too hung up on the AI as AI, but really to think, what can you learn from AI? What can you learn from biological, you know, systems and so on? So I think that will be the key question. In terms of the work you presented, it was really fabulous. I think I was more convinced by the kind of the thing you had on that kitchen table, this kind of beehive thing, than the Nefertiti one, where it was conforming to a particular kind of structure. But you know, I think you're approaching it from a number of different sort of angles, and it's actually a very beautiful work. But I would almost privilege the notion of intelligence. That's really, it seems to me, what you're getting at. But fantastic work. You know, carry on. That's great.
Thank you.
Hi, Ahmed.
Hello.
Appreciate your presentation, but I still want to put forward the dangers of artificial AI. The scenario you make use may be followed by the theory from Neil and also the workshop from Daniel. I think a designer or have some very strong ontological logic in all their own discipline. Architecture discipline is there, and the new technology is there, but sometimes not means 1 + 1 means 2, not means digital fabrication plus AI means future architecture. I think it's dangerous just add some new topic, new knowledge to architect discipline and talking about that is the future of architecture. I think extremely dangerous. It's kind of misunderstanding of what is architecture, what is innovation possibilities through digital fabrication, through artificial intelligence can give real contribution to the future of discipline. And I think it's really meaningful for this kind of biology research or biomimic design process to learning from nature and learning from the structure from nature. I think it's a meaningful process. And also you mentioned some architecture without architects or some artist work without artists. I think it's really like the creative process is not embedded in the designer space process. And you're learning from them. I think that is meaningful and reasonable and also interesting research and methodology. I think it's rational or it's reasonable. But when you introduce architecture intelligence or artificial intelligence into the design process, I think you should firstly understand what is that. We try a lot actually in past 2 years when New actually introduced this methodology in the community. I think we have huge numbers of students, undergrad students, graduate students, and PhD candidates. They're all learning or try to make use of different scenarios, followed by artificial intelligence, which can give a new consciousness or new possibilities to generate different form. But I think right now it's probably artificial intelligence is not a real intelligence which can replace the human consciousness or human imagination. It could be only a kind of certain kind of semiological or new formalism, a new formalist like Daniel maybe probably is one of them. He is a very good designer and he can make use of this kind of methodology very well. But it's that not means you borrow or introduce his methodology into your design can make a really good design. And sometimes I think the scenarios, if you talk to some structural engineer, they introduce artificial intelligence into certain process of the database research process that is meaningful. Or maybe Wang Yuhe, she actually introduced artificial intelligence in the layout formation of different residential program or projects in China. That is probably some scenarios successful make use of artificial AI. But I think AI right now is just a kind of new possibility. If you fix too much in the robotic fabrication or three-dimensional printing process to printing some form and talk about that form is a new intelligence, I don't think that is reasonable. Sometimes it's kind of dangerous to leading you to some misunderstanding of the technology. So I think my suggestion to your thesis or to a PhD, you should still keep understanding what is architecture design and what is a discipline. And then you're learning and borrow from knowledge from this kind of new technology will be a good way of how to learn this kind of new technology. It's not just A plus B means C. C is just because I make use of this new technology means this is a good architecture. I think that is maybe not a very reasonable learning process from the expertise, from the theorists, and from the good designers. They are technicians, but maybe you are not. So I think it's still a long way to be really careful to talk about technology before you become a really good technician. So that's my comments. Maybe you have different thoughts, but I think I can see the dangers of education from expertise. You should be careful on this kind of new knowledge. New knowledge, maybe on the one hand, it can give a special engine to the development of discipline, but sometimes it's really dangerous to driving you to falling down to the cliff. So you be careful of that. That's my comment.
Yeah, thanks for your point of view. I appreciate it. I have a lot of comments actually on this point of view. Firstly, I'm not doing a PhD in architecture school. It is architectural engineering school. So I'm not looking from architectural perspective. So maybe you build your conclusion as if I'm doing my PhD in architecture, but it is not in architecture, it is in architectural engineering. So this is a first point. So if you look back from what I just presented from a point of architectural engineering and more into engineering, I'm not looking for AI as a design tool. I'm looking for AI as a nest, like this Wasp is using design to fabrication process. So AI is somehow a tool. It is not just cycle GANs and picks to picks. I believe your comment was based as if I was planning to use cycle GANs and picks to picks, but the point is I'll be using computer vision so the software can see the elements of, let's say as example, the hive, analyze the depths, the heights, and the elements as an engineering, and then look for possibilities for aggregation and so on. This is the first point. The second point, I totally agree with you that it is not, we should not just take AI as a design tool. It is not yet a design tool. But if you, my published paper in ASCAD 2021, using the AI, it was like experimenting the possibilities out there to manipulate a surface. But it is like, when I started my PhD, I started with the observations and then went for experiencing using the AI. And then I went back for my lab to experiment the material itself. And then I went back for AI to build more understanding of this kind of element aggregation in a hive or a wasp nest and so on. But yeah, thank you for your comment. I will consider every point of view.
But maybe that's the point, right? I think that's the beauty of architecture. You get so many different viewpoints of view, and it is a contested domain. I mean, I have to say that I couldn't disagree more with Philip what he said just now. I'm sorry, I find it problematic that AI is being understood in this way. AI is really a thinking tool. You know, to my mind, it's a thinking tool for rethinking some of our questions. And the fact that it's dangerous, well, that's good, right? To my mind, it should be, you know, I think this is the role of theoretical thinking. You know, that's why I think Zizek is so important, that he's described as the most dangerous philosopher in the West. But he is the most useful and necessary philosopher because he questions and challenges all these assumptions in such a kind of intelligent way. And I would just say that, you know, to my mind, a thesis is really is not about making a thesis, but asking questions and things. And it goes back, that issue is really, what is the architecture is all about asking the right questions, and so is a PhD program. So I have no problems with that, and I worry about sort of notions such as meaningful and so on. Whose meaning is that? You know, and I think we've got to really keep this debate alive and open up to these impulses and not see them as not fetishize them as form makers at all, but as tools by which to think with. That will be my assumption. And I just think that AI is incredible in what it's opening up, and we mustn't be closed-minded about it and dismiss it as a form-making tool, because that's not what it is at all. You know, it's really a new way of thinking. It's this kind of opening up and challenging, keep architecture alive. But you know, it's great that we have these differences of opinion. That's the nature of architecture, right? I mean, it's fantastically rich because of that.
Yeah,
we do need to move on, so let's just get some closing comments.
Oh, I just wanted to
comment.
No, let me chime in, Ahmed, real
Yeah.
quick. I just wanted to say thank you for your presentation. I would say that I have not been around architectural engineers, but I have been around electrical engineers, computer scientists, and scientists per se. So you have a lot of territory to, if you want to redefine what architectural engineering is in the field as a hybrid, I think that is a huge goal. But my thoughts are that you have all the energy and capability you can to challenge, you know, theoretical frameworks and, you know, computational infrastructures of AI, but also just frame your problem so that it's not going to take away from your purpose. So whatever your purpose is, just understand that we're mortal and we have a small amount of time. So thank you.
You want to say something, Ahmed, finally?
Yes. So in conclusion, I will the AI will be a kind of simulating the action done by creatures out there in nature. We remember when they simulated the swarm intelligence of birds, let's say as example, or if they simulated the swarm intelligence of ants. So why we don't agree that we can use AI to simulate the same behavior of wasp, but not just the behavior, but it's the design by fabrication process it uses to build their nests, and then look for possibilities can be done considering the physical characteristics of the material. This is my main point of view. Thanks.
All right, great, thank you. We will move on now to our final presentation today from Maria Kuptsova. She is a Russian architect who is studying at the University of Innsbruck under Claudia Pasquero. She's entering her third year of her PhD, and the title of her presentation is Biotechnics, Implementation of Biomechanic Intelligence into Design Protocols.
Thank you very much, Virginia. Thank you very much, everyone, for inviting me to present today. It's a great pleasure. I'm impressed by the project from the previous presenters and also by the comments. It's also so relevant for my project that I was just taking notes and now a bit worried of presenting my presentation, but I'm looking forward to the discussion. I start sharing my screen.
Yes, we can see it.
Yeah, thank you very much, Virginia. So the title of my PhD is Biotechnique or Biotechnica. You can see it also in Cyrillic. So and basically, I'm aiming to develop a biomachinic design protocol or method, which will be merging biological and artificial intelligence within the design strategy. And I really aim to contextualize it in a new form of material and formal articulation. So basically, I'm aiming to set up a new design protocol. I'm working with the genius Claudia Pasquero at the University of Innsbruck Synthetic Landscape Lab. So today, I think that with the progress of synthetic biology, robotics, and any other development of the technologies basically enable a complex design platform along which inorganic, technological, and ecological agencies are becoming symmetrical. Simultaneously, with the collapse of biodiversity, the technodiversity is reopened. We see a strong potential for an explosion of new design methods taking form through robotics, synthetic biology, and artificial intelligence. In this discourse, the concept of naturality is changed, evolving its meaning from romantic first nature to a nature understood through the concept of cosmotechniques, which conceptually avoid the opposition between nature and technique. New thinking integrates modern technology into the tradition and also transform this tradition in order to reopen the technodiversity. Here I quote the Yukwe. The environment actively engages with everyday activities, and the advent of planetary smartification means that recursive algorithms will constitute the major mode of computation and operation of our future environment. The technosphere is included into ecological thinking, and ecology is understood as a natural technicum continuum. And here I give a reference to Edward Burtynsky and his observation of the landscape disturbed by the human activity. And Edward Burtynsky is observing the patterns and by the human and all the processes which are present in our environment. And what is interesting that I think that basically the planet and the landscape that we are looking now on is becoming this synthetic system where technology is not anymore distance from the biology, and the human agency here is the same. So basically, by setting up a design technique, we need to talk about the three different systems: technological, biological, and human. Or do we actually can we actually make a distinction between them? But basically, we need to blur them and form a new design language. And in order to form a definition of the biomachinic design intelligence, I study a large database of existing project references and literature. And beside the classic way of reading and investigating this literature in the projects, I also was doing in my first step of PhD an interesting experiment which was involving the artificial intelligence within the process. And I was using generative pre-trained transformer network algorithm as an instrument to enlarge the database and basically to read with machinic intelligence a large archives of the data. And I think I've got some interesting conclusions from here that helped me to push my research forward. So I won't stop here very long. And I was also doing some experiments with contrastive language image pre-training to convert this readings into the this kind of machine learning drawings. And as a second step of my PhD, I was looking into my teaching-based research and my previous practice that I was doing in the University of Innsbruck Synthetic Landscape Lab, as well as at IAC Institute of Advanced Architecture of Catalonia, UCL, Bartlett, and also some of my individual practice. And here we are basically looking to the landscape and to the Earth and the cosmos as the large transformed gigantic technological system. Now, and basically a design that we implemented is an evolutionary design system, which is merging machinic and biological system and going from the microcomputers now to the scale of the planetary scale computation. And I will just very quickly go through some of the projects that I am analyzing and basing on my own. I'm bringing you here to the Alps. It's one of the diploma projects that you are developing with Matthias Wienerzer. And we are looking into the system, which includes the technology into the design system. So basically, we are looking into the modification of the landscape by the means of the conversation between the human, machine, and the landscape. And we are proposing a system for the landscape, which could be modified by the machine in order to become usable for a human and for the nature. Now, and here, what is interesting, the design apparatus is becoming a way of becoming a conversation between the machine, human, and the environment. And what if we are looking into the material intelligence and thinking how the material intelligence start driving the design apparatus and then starting to form a new design system based on the composition and the proportion of the material constitution. Here's one of the project that we are studying, the biorock materials, in order to create a large coral reefs for the protection of the exposed to the overflooding. I will go very quickly. And what if we are looking actually and starting to design this type of agents? Now, what if we are looking into the technology itself and starting to design them? And this is one of the projects that I was developing with the IAC team for the Tallinn Biennale back in 2017 or 18. And we were basically designing the drone and enlarging it in order to show that basically these technologies are on the space, are on the planet, and we can transform the understanding of the technology from this kind of mechanical creatures to the biological. Or what if we are looking into the different type of agency? Here I need to say a reference to Ahmed and to the previous presentation, and we are looking to the real neighbors that we are living together in the Alps, working with the bees and studying how the bees are capable to construct the system and how we could basically co-build by hacking their construction knowledge, the construction system, and adapting to them in order to form a new type of structure. And what is interesting that here, I think the design apparatus turns to be a dynamic biosynthetic system, where again, as I repeat myself, machining, biological, and human agency are paired in the action. And design apparatus here is organismic. And basically touching to the architecture, I think what is interesting to discuss is an architecture which takes the form of post-nature. Bringing my research further, I started to set up my individual experiments, and basically a possibility of developing a design technique which will be based on my previous experience and will be basically grounding itself in the biomachinic intelligence and could contextualize these experiments in the new form of material and formal articulation. And basically I'm aiming to impart this biological intelligence into the design system and bring it into the design objects and the synthetic environments. So, and this workflow outlines a set of biomachinic methods, which basically creates my strategy. And I look to I want to bring you back to the landscape, and now it's another part of the planet. It's Russia, somewhere next to me here in the north. And I bring you to the forest, and I want to talk about the materials. And I was starting defined as structural or functional, and regarded as a feature of form and not as its originator. In natural system, as we see here, for example, in the forest, it is difficult to differ between structural and functional materials. Biological matter is heterogeneous and informed through the direct relationship with the environment. Shape results here from bottom-up material organization, sophisticated sophisticated property gradation, functionally hierarched in the single material system. And basically, in order to start my research, I'm looking into the wood, and wood is widely used in the architectural construction for its mechanical, ecological, economical, and acoustical properties. Some novel projects explore also the elastic and hydrophilic properties of the wood. But basically, this architectural heterogeneous material properties are usually considered as the negative for the materials which are used in architecture. But what I'm interested in it's basically in the wood biological state, because in its biological state, the system of wood has a beautiful vascular tissue, and which is basically capable to keep the heterogeneous properties, basically keeping the elasticity, keeping the strength, the load-bearing properties, the food production, the information exchange, etc., etc., etc. So in order to study my research, I took a large database of the timber structures, and I'm studying them in the 3 anatomical cuts in 3 planes of symmetry, and studying basically the formation of the wood structure with the style gun. So, and basically I'm to the anisotropic properties of the wood, which are quite crucial for the timber structure, and which are responding to the needs of the wood and trying to bring it into my design system. The style gun variant of generative adversarial network here is used as a method for extracting material organizational principles from existing database of timber structure. And basically, I'm further implementing it in the volumetric model that I will show a bit further on. GAN's architecture for training allow us to generate larger data sets of biodigital structure using the style transfer. So for this specific, I will maybe go a bit further. For this specific experiments, I'm using 200 magnification and comparing different section cuts in order to compose the final model based on the latent vector. So the latent space here is actually a very interesting point for me within the style gun. Now, so basically, this kind of each artificial proposition in between the each non-fake images is creating this latent space, which is forming the latent vector. And I think that this becoming kind of a space for experiment for me. So there is a lot of material on that, and I'm studying as I was saying, the different section cuts. And in order to start modeling the final volumetric model, and which is basically consists of the comparative analysis of 3 different anatomical cuts in the structure. And here you see that the latent vector of my style gun experiment is converted to the Z vector of the morphological structure. But don't look at them as the maybe final design experiments, but look at them more as the material experiments. And basically this discontinuous, like I'm converting later on the all these different steps of the like later vector, I'm converting them into the point clouds and voxelizing them and creating, let's say, the discontinuous data sets or data sculptures, which contain information of the material organization principles, such as allocation of stiff and soft materials within the structure, gradients of fiber densities, as well as variation in hydrophilic properties within the structure. And these principles replace digital form finding based on form optimization to a potential programming within the design object. And I think this opens up a possibility to design and fabricate architectural components with varied properties within the structure, supporting the integration of functions within the material, such as load bearing, informational exchange, natural ventilation, hydrophilic properties, among many others. And I think that here, this type of the structures, and they are bringing for me the idea that this design objects made of kind of reprogrammed through this biomachining design means, they are not following the idea of the form finding by the maybe load bearing and structural distribution, that basically they're extracting the information from the material and starting to drive this into the design. So, and by that, I'm designing a different steps of the 3D printing technique, and thinking how I could further on set up a biosynthetic material printing, and this biodigital matter that let's call it this way, or biosynthetic matter, is not anymore an amorphous matter, no, but it contains the, and the structure operates at every level of scale. And the fabrication techniques as the additive manufacturing or multiscale robotics techniques will allow for the development of adaptive fabrication methods informed by research and material behavior. And so basically you look at this materials as the steps for the as a kind of next steps for my fabrication. I know that I'm getting a bit late, so basically now I'm starting the step when I'm setting up a large-scale 3D printing technique, which is rethinking the use of the wood, converting it to the fibers and to the wooden powder in order to set up a 3D printing. I don't go through that because it will take time and this part is not completed. I hope that I could present it to you as a next iteration of my studies. But maybe as a last chapter, I would like to show you very briefly some experiments that School of Architecture with the Morphogenesis Lab, where I had a chance to run the workshop with the colleagues of mine. And we are basically looking here to the same instrument of the machine learning and thinking how we could extrapolate the information from the landscape and now inform the landscape with the same set of the techniques in order to set up a design strategy. So we are extracting the same pattern and reading that pattern by the means of machine learning techniques similar that I was showing you before in order to create a next step for the design proposal. I'm trying to conclude, okay, Virginia. I think here we are looking into quite an interesting possibility to start thinking on the certain type of the automation of the design, but which is not driven anymore by no, it doesn't work. Which is run not anymore only by the human intelligence, but which is structured by the collaboration of the human, technological, and biological agency, and all the systems are starting to collaborate in order to set up the next design iterations. Stop here. Thank you very much for listening to me. I hope it wasn't too fast, and thank you.
Thank you so much. So sorry to rush you at the end, but we do have to keep moving on. So let's hear some feedback from our critics. Professor Philip, or do you have any feedback?
It's great presentation, Maria. I think it's a really, really good research. I really appreciate what you're talking about. It's really clear about you're talking about the biosynthetic methodology to generate different new materials, especially a very strong coating from the research from the wood. I think from the theoretical perspective, it's really interesting to talk about the post-human and post-nature. I think right now to engage the computational design to the nature and to the material science or material intelligence is really very, very interesting. And also my team is actually also make similar research to doing some micro material performance-based design in 3D printing. Although the scale is different, but I think I really appreciate your methodology to use style GAN to generate a composite material, which is based on the logic from CLT or from different kind of wooden materials. So this is really a good scenario or methodology to implement this style GAN or style transfer and make use of them. And this is a really good scenario you present for making some new materials based on the artificial intelligence. So what I want to say here is sometimes when we talk about the new methodology or new techniques, I think we still should have a very strong common ground or still fundamental research on the materials or on our discipline. So I think I appreciate Maria has a very good presentation to have a narrative process to analyze the biological, biomimic process of learning from nature. And the digital material actually is our future, because when we're learning from nature, we can make extremely interesting some new materials. And based on the style GAN or AI, I think the logic is there, as you we can see a lot potential quality or potential performance on materials. So that will give us a new, totally new new boundary to extending our boundary in architect discipline. So very good, very good. I want to hear something maybe from Neil. Yeah.
Thank you very much.
Yes. Yes. Maria, do you want to say? Yes, sir.
No, I just wanted to say thank you very much for the comments.
Yeah, in a way, I think, I mean, fantastic work, of course, and actually all today's presentations have been really fantastic, and I'm really impressed by them. And actually, in some ways, we've already, I think, as you noticed, we've already addressed some of the questions in some way in the previous presentations. So I just wanted to just kind of like to do a kind of like a bit of a kind of meta commentary in some ways, because I mean, one of the things I find interesting is the fact that you studied at IAC in Barcelona, which I think is, I just want to use this because, you know, maybe you don't realize this, but we're using the term digital consortium to describe what we're doing right here. The term digital consortium was actually coined, or at least I coined it years ago, because we were trying to set up a platform for doctoral research in computation. And it was kind of coming out of the problem at the AA, where we had all these students in the AA DRL who were graduating with nowhere to go. All they had was the London Consortium, which actually was great in its own way, but it was just a humanities-based thing. There was no computational-based PhD program. And anyway, so I was, this is about 2007, 2008, I was in discussion with the guys at IAC, Vicente and Alessi and so on, about setting up what we call digital consortium. And the idea was that I was then at the University of Brighton, which was a validated, if somewhat boring institution, you know, and then IAC was this completely, you know, experimental, you know, risk-taking, whatever, you know, and it was actually a beautiful potential, but it kind of collapsed because the University of Brighton was worried about risk assessment and all these kind of questions, which, you know, to my mind, is we should be taking risks here, you know, absolutely, you know. So it didn't happen, but then a second iteration happened at the European Graduate School, where we had a PhD program, and I think some people are there now. That, for some reason, was closed down by a very conservative dean who came in who didn't believe in computation. So we set up the one in Tongji. We had a few challenges there. And in fact, the next iteration has been the DDES, Doctoral Design Program at FIU, where we're kind of trying to take it to another level completely. And I don't want to go into that. But anyway, so it's kind of part of a process. But it always struck me that IAC has a really interesting role to play, because IAC would not have existed if schools of architecture had been teaching the kind of material they should have been teaching, right? It was just left out. So IAC was there as a kind of supplementary thing where you would find out about all these computational tools that weren't being taught elsewhere. Now, the interesting thing to me was actually that is the same argument that is kind of made for Uber. Uber would not have existed if taxis were efficient enough in the first place. And really, I mean, so what happened, of course, was that Uber came along and forced taxis to readdress what they were doing, you know, and that's an important thing. So, you know, almost like the logical conclusion of IAC and the logical conclusion of Uber was they cancel themselves out, that everybody is doing what they're doing, and therefore we've improved the situation by challenging that thing. And of course, that model of Uber has been used by Philippe Morel to describe exactly maybe what we're trying to do in digital futures to standard education. We're trying to kind of like, you know, force it to improve its act by bringing on board all these kind of questions and so on and so on. I would just simply say that, you know, I think what we have here is the possibility of seeing what a doctoral research is doing exactly the same thing. A doctoral research being some kind of way of challenging the norms and the accepted way of doing things in order to kind of keep something alive. You know, tradition is not static. Tradition is dynamic and it's alive. And I think what I've seen today in all four presentations is really impressive contributions to keep architecture as a debate alive in some way, you know. And the danger is if we remain fossilized, you know, because fossils are out of date, right? We've got to be adaptive like biological systems and change and shift. Like, in fact, the Deleuzian notion of we've got to be deterritorialized, rhizomatic, and not striated, caught up in this structure in some ways. So, to my mind, you know, that's the role of this kind of work, is to keep architectural debates alive. I'll finish with one simple comment, and that is a story about a professor. And I've told this several times, so my apologies if I told it to you before. But this professor, when he was young, the lecture hall was completely full. Everyone was packed in to go and hear it. By the time he came to the end of his career and he was retiring, there were about 6 people in the front row. And he said, I just don't understand it. I'm giving exactly the same lectures I gave 30 years ago. That is the problem, right? That is the problem. What we have in education is really a problem in the sense that we have people teaching who did their PhDs on Le Corbusier 30 years ago and are still teaching the same material. To my mind, we have an obligation to keep education alive, and to keep architecture as a debate alive. Architecture is like a shark. It has to keep moving. It has to keep going in order to be what it is. So I think what we've seen today is some really impressive. I mean, I'm full of optimism after seeing this, because you guys are the future, and you'll be going in, and I think doing exactly that, doing what Uber did to taxi drivers, or doing what IAC did to standard education, and I think that's so important, so important. So we'll never agree on everything, but that doesn't matter. We haven't got to agree. We've got to, maybe all we got to agree on is to keep architecture alive in some way, in this way. So I just wanted to thank all of you. I mean, I don't want to get into detail of all of you, because I was so impressed by today. The standard of the interrogation was really, really good. And there was no singular model. That was the beauty of the thing, and I just want to repeat, there is no singular way of writing a PhD. It's like there's no singular way of designing a building. There are many different approaches, and I think it's important to keep all those approaches alive and keep them going in order to keep architecture itself alive. So I'll stop ranting now. Thank you.
Thank you, Neil. Always so inspiring. Thank you so much.
I guess I'll chime in. Maria, thank you for your presentation. Very clear. I just want to put a name out for you. There was a professor that I met at UCSB who actually was foundational to the field of making Gorilla Glass. And he came and spoke in in my class, in its transvergence with Professor Marcos Novak. So what was keen about this person is that he studied squid, and he studied how the skin works, and he studied skeletons, and he speculated on future research. But with that knowledge, he actually redefined an entire category of material at the structural level. So Dan Morse is the professor, and his student actually created a lot of the technology, the 3D printing technology for Neri Oxman. So there's a lineage between fundamental basic research. He understood the physics, the mathematics. He understood at every basic level how it worked to create a new material that changed the entire product line of how things work, and made a new basis for art just by his students moving forward. So now going back to your research, I really enjoy the pipeline, and I really enjoy the machine, the AI and the learning part of it. But I would also question, what if you put yourself in different methodologies? Are you that scientist that's going to make new materials that is going to go out and change our space exploration, let's say? How do you test those materials? So I think the testing is important, the measurement, the quality. If you think about this as aesthetics, I don't think there is a measure of aesthetics. I think it becomes philosophical. So, and then the other thing is that if you wanted to think about this conceptual framework that you're laying down, if everything can be augmented and changed and formed, then what is your overall, claim? So what are you doing that's going to change the future? So I think is your problem, hey, I use machine learning or AI to make new different materials, and at a core foundational level, then I'm making these new forms to be sculptures, to be building materials? Is it going to absorb different moistures to help us, survive climate change? Like, what are the testing mechanisms? And finally, what I would say is look at the other sciences, because architecture, I'm coming at it from traditional, I'm third generation. So architecture, I had to go out and now I'm coming back in. The sciences and engineering are so key because I think from MIT, what I understood was, hey, they're combining art, science, and tech and making these new leaps of knowledge. But when you go to a research institution and you work and see the scientific laboratories, it is a different domain. So I think that what you're doing is definitely laying a claim. But what knowledge are you building on? Like, what shoulders of giants are you standing on of different professions? And I think that's going to offer more credibility to what you're claiming at different fields, because architects are just not, I think, architects. We have to solve other problems. I believe that in what you can do, you could help a material scientist make a new discovery. How can we combine different metals or glass, and how can we make new forms or new building material? I think Philip could probably speak to that more in his research. But I very much thank you for your presentation.
Thank you so much, Gustavo. Such a brilliant comment. Yeah, I'm on it. I'm testing. I will bring it next time. I promise. Please invite me once again in half a year. I will show you much more. I promise. It's ongoing. And but maybe for at this moment, I'm just to answer you. I'm aiming to design a framework which will allow us to look into the non-human systems and take them into the account within our design process. So I think this may be now a key aspect, because I think that our design system itself, the methods that we are using, are not looking into the non-human agency in any state, technological, biological, etc., because we didn't create this culture. And that's what I'm probably now in this, my first steps was focusing in. But now I absolutely agree with you. Okay, now time for testing.
Maria, one last thing. So the other gentleman's name is James Weaver from the Weiss Institute. And so he gave a lot of these tools to Neri Oxman. So how do I know that? He came to my institution, he spoke with his mentor, and he was so open with what he knew. But he knew how complex it was to even get there, right? So I think that you have a lot of energy and drive that you could make those new tools. You could make the teams. But what is the leap of faith? And what do you want to leave us with? Is it new art forms? I think you can make art, new material, and new theory. So congratulations.
Thank you,
All right, thank you. Thank you for your feedback. We can definitely continue these conversations through email, through messaging, but I just want to conclude today's panel with a great thank you to all of our presenters. Thank you so much, Sina. Thank you so much, Anna. Thank you so much, Ahmed. Thank you, Maria, for your presentations. And thank you, Philip and Neil and Gustavo, for all of your feedback to the presenters. Are there any other closing comments from the presenters or the critics?
I would say thank you very much for all of the presentations. They actually challenged me so much and how I believe and think about architecture. And you guys are the future. So I'm very thankful and grateful of your time.
Thank you.
No, just one final comment, and that's to say, there needs to be no comment on this, because they speak for themselves. Really fabulous kind of comments, and I just think that, just in terms, I was just iterating a kind of like a genealogy of just now about how different doctoral programs have kind of evolved and so on. And to my mind, the next step is really precisely to consolidate this as a platform in some ways. It came out of the experimentation we're doing on the FIU DDES, where we had everybody come and join in discussions, which was incredibly fruitful, because you have this communication, this kind of thinking together, this computation, as I would call it, and so on, this kind of global brain. And now the possibility exists for this platform, which I think really will help in some ways, because you can be in somewhere remotely doing your PhD, and you really need to kind of get the support of others, kind of like a support group almost, to find out what's going on. And there's a danger that you fall out of touch if you're kind of, you know, speculating somewhere in the nice place in the world, but not really engaging and finding out what everyone else is doing. Here, you really got a sense of where the debate is and the kind of standard that's going on. And it was so useful. And I hope that this is just the beginning of something. I don't know quite what it's going to lead to, but I mean, I just think that for a PhD where you're working in isolation and it's such a solitary, personal crusade in some ways, you absolutely need this kind of this platform for debate. So thank you so much, and thank you Virginia and the team and Gustavo and everyone else for setting this up. This has been this is vindication, I think, of what we were thinking about, and it's really showing how important it is to have such a platform. Thank you.
Bye-bye. Thank you.
Thank you so much. Bye-bye. See you soon.
Bye-bye. Thanks.
Spasibo.